June 19, 1966. The golden light of dawn spread over the legendary Le Mans circuit. The roar of engines tore through the morning mist, and three Ford GT40s crossed the finish line in unison, taking first, second, and third place. It was not just a victory. It was a crushing blow to Enzo Ferrari's pride, delivered on the very ground he once ruled. Hollywood turned this moment into a heroic tale of drivers, but behind the spotlight lay another truth. This triumph was built on the heart of a pure mechanical beast, the Ford 427 side oiler, an engine created not merely to win, but to utterly destroy the competition. This story does not begin with glory. It begins with betrayal, a personal insult, and a burning desire for revenge, the driving force that pushed Ford to create the machine that would rewrite Le Mans history. In 1963, Henry Ford II seemed to have one foot in the European racing world when he reached an agreement to buy Ferrari. Every term was nearly finalized, champagne chilled in anticipation of the signing. But then came a cold telegram from Modena. Enzo Ferrari cancelled the deal at the last minute. Worse yet, Enzo delivered an insult Henry Ford II could never swallow. "You are nothing but a fat tractor salesman." For a man carrying the pride of American industry, it was a slap to the face. Ford's response was immediate, turning anger into an audacious plan for revenge, to beat Ferrari on his own sacred ground, the 24 hours of Le Mans. But at that time, Ford had no real endurance racing experience. Their engines were fast in a straight line, but lacked the durability to run flat out for 24 hours. In 1964, the GT40's debut at Le Mans ended in disaster. Every Ford retired with blown engines before the 9th hour. The press mocked, saying, "Ford's tractors belong in cornfields." That humiliation turned Ford's determination into a vow to build a machine powerful and durable enough to wipe the smile off Ferrari's face. In that moment, a little-known name stepped out of the shadows: Bill Innes. He was not a star driver, nor a public figure. Innes spent his days at the drafting table, in the workshop, and around freshly cast-iron blocks, where every mistake could cost a blown engine on the track. The FE block's greatest flaw was how it kept its own heart alive. Its top oiler lubrication system sent oil to the top end first, leaving the crankshaft, the most heavily stressed component, with whatever pressure was left. On the street, that might pass, but on the racetrack, it was a death sentence. Innes proposed a solution never before attempted: drill an oil gallery along the side of the block, parallel to the crankshaft, to prioritize lubrication of the main bearings first. This not only altered the FE's structure, but also drove production costs to a painful level: over 200 hours of machining per block. Yet Innes believed that if Ford wanted to beat Ferrari in the world's harshest arena, they needed a new heart, a foundation strong enough to build the ultimate machine. And from here, the technical story of the 427 FE began. When Ford set out to turn the FE block into the foundation for a purpose-built racing engine, they didn't just enlarge it or add more horsepower. They redefined how an American V8 could be built to withstand sustained high-speed punishment for dozens of hours. The 427 block was cast from high nickel content iron, giving it exceptional resistance to distortion and wear. A thicker deck allowed compression ratios up to 12.5 to 1, something few street engines could attempt. Its big bore, short stroke layout, with a 4.233-inch bore and 3.784-inch stroke, delivered smooth, high-rev capability but limited safe overboring to 0.030 inch to preserve structural integrity. Load-bearing components were designed as if for a mechanical storm. Strengthened main bearing webs secured by cross-bolted caps, a forged steel crankshaft built for extreme loads, and solid lifters ensuring precision at high RPM. On paper, 410 to 425 horsepower was an enviable figure. But on the racetrack, it was the block's rigidity and endurance that truly mattered. And that is why, despite its promise, the early 427 FE endured painful failures before becoming a legend. In 1964, at Daytona and Le Mans, the cars powered by the new engine quickly revealed a critical weakness: insufficient durability to survive the brutal demands of endurance racing. Within hours, Ford entries began dropping out, their engine bays blazing hot and reeking of burnt metal. Oil pressure steadily declined at sustained high RPM, subjecting bearings and crankshafts to severe wear. Combined with intense heat from the high compression ratio, many cars retired with blown head gaskets or warped cylinder heads. The 1965 season brought little improvement. GT40s still failed to finish, and with each defeat, the press found fresh reasons to doubt Ford's capability. Ferrari, meanwhile, grew ever more confident in its technical superiority. These losses were more than costly lessons. They were warnings. Without a decisive fix for lubrication and heat issues, Ford's dream of toppling Ferrari would collapse. And that was when the side oiler concept emerged as the lifeline Ford desperately needed. Instead of sending oil to the camshaft and valve train first, as in the top oiler design, the side oiler prioritized oil flow directly from the pump to the crankshaft and main bearings, before feeding the top end. This ensured the most heavily loaded components were always fully lubricated at high RPM. Adding the side-mounted oil gallery required a complete overhaul of the casting and machining process. Foundry molds had to be redesigned to integrate the new passage while maintaining block strength and ensuring stable oil flow. A high-capacity oil pump and precisely calculated distribution channels were added to avoid pressure loss to other areas. Beyond lubrication improvements, the side oiler retained the 427 FE's robust upgrades, reinforced main bearing webs, cross-bolted caps, forged steel crankshaft, and high compression ratio. Together, they created a platform capable of running for hours above 6,000 RPM without burned bearings or a broken crank. But once the side oiler was ready, a new problem emerged. The drivetrain couldn't handle the power it produced. Transmissions and differentials originally developed for smaller engines quickly showed their limits. In the GT40, the transaxle built for the 289 cubic inch engine suffered from broken gear teeth, failed bearings, and oil leaks after intense stints. In NASCAR, 4-speed gearboxes and clutches faced the same fate, wearing out or burning after only a few hard launches. Carroll Shelby, directly in charge of the GT40 program, wouldn't stand for it. He declared that without a transmission strong enough to carry the side oiler, he would walk away from the project. Ford responded by developing the T44 transaxle specifically for the GT40 Mk2, along with reinforced driveline components and heavy-duty clutches. Now, both engine and drivetrain were ready. On June 19, 1966, as dawn broke over the Le Mans circuit, the showdown the world had been waiting for erupted. Ferrari brought its 330 P3, about 200 pounds lighter and making 450 horsepower, while Ford fielded the GT40 Mk, two armed with the side oiler and the new T44 gearbox. This was not just a speed contest, but the ultimate test of mechanical endurance. On the nearly 4-mile Mulsanne Straight, the GT40 Mk2 sustained speeds over 200 miles per hour, holding steady revs with oil and coolant temperatures safely in range. For the full 24 hours, the side oiler suffered no bearing or crankshaft failures, issues that had haunted Ford in previous years. When the clock struck the final hour, 3 GT40 Mk2s crossed the finish line together, taking first, second, and third place. Ferrari, once the untouchable icon, was forced to watch all of its 330 P3s retire from the race. This victory was more than a sporting triumph. It was an American engineering statement, a direct answer to the insult of 1963 and proof that when designed right, an engine could be both powerful and unbreakable. After Le Mans 1966, the 427 side oiler was not just a legend in Europe, it became Ford's primary weapon in American racing. In NASCAR, it quickly proved its ability to withstand high RPM and heavy loads over 500 miles. Fred Lorenzen, Fast Freddy, used the high-riser-configured side oiler to win the Daytona 500, maintaining speeds over 180 miles per hour on the 2.5-mile oval. Ned Jarrett, the 1965 Grand National Champion, exploited its massive torque to win on a variety of tracks, from Darlington to Charlotte. David Pearson continued that success in 1966, taking victories at Talladega and Bristol, showing that the side oiler was not only fast on straights, but durable in tight corner racing. In drag racing, the side oiler appeared in the Ford Thunderbolt, a Fairlane optimized for the quarter mile. With around 425 horsepower in stock form, the Thunderbolt easily ran under 12 seconds, forcing Chevrolet and Chrysler rivals to take notice. Drivers like Gas Ronda and Dick Brannon took advantage of its instant torque for blistering launches. When modified with dual carburetors, aggressive camshafts, and high-flow heads, the side oiler could reach up to 2,000 horsepower in funny car and top fuel trim. Though at that level, the block required constant maintenance to avoid cracking. But that power wasn't limited to straight-line racing. Carroll Shelby found a way to channel it into a sports car where speed and agility worked in harmony. Shelby took the lightweight chassis from AC Cars in England and re-engineered it to house the 427 side oiler. The result was the Cobra 427, a compact roadster with the heart of an endurance race engine. In street trim, it produced around 425 horsepower and could accelerate from 0 to 60 miles per hour in under 4 seconds, an astonishing feat for the mid-1960s. In SCCAA production racing, the competition spec Cobra 427 with over 500 horsepower beat both Corvettes and Jaguars, thanks not only to straight-line speed, but also to its ability to maintain stable oil pressure through high-speed corners. The Cobra 427 became proof that the side oiler could shine both in sports cars and in race machines, even though major challenges from rivals and regulations still lay ahead. In NASCAR, the clearest threat was the Chrysler 426 Hemi, a hemispherical combustion chamber design that gave the engine excellent airflow and durability at high RPM. In response, Ford developed the 427 single overhead cam, CAMA, producing over 650 horsepower. But it only had a brief moment before NASCAR banned it after Chrysler's protest. In endurance racing, Ferrari's P-Series continued to apply pressure with lightweight chassis and finely tuned V12 engines built for long-distance performance. On top of that, technical regulations changed frequently, from displacement limits to emerging emissions requirements, forcing Ford to adapt its strategies and engine configurations. These pressures came not just from rivals, but from the rulebook itself, where sanctioning bodies could shift the framework to prevent any single manufacturer from holding dominance for too long. And soon, it wouldn't be just racing rules, but the market and government policies that began to turn against it. In the late 1960s, regulators began tightening emissions, paving the way for the 1970 Clean Air Act. High-compression, fuel-hungry, high-emissions engines, like the 427 side oiler, became prime targets for elimination. At the same time, insurance companies sharply increased premiums on muscle cars due to high accident rates, making them less accessible to everyday buyers. The market began turning away from street-going race machines, shifting toward more moderate performance cars with better fuel efficiency. Ford was forced to replace the side oiler with new blocks like the 428 Cobra Jet and 429 385 series, still powerful but more compliant with emissions standards and street demands. By 1970, the side oiler was officially discontinued. With only about 300 street-legal examples produced and many blocks destroyed after racing seasons, it became an instant rarity. A legend closed its chapter, leaving a void in the golden era of American big blocks. And over time, that scarcity would ignite the collector boom of the 1980s. Enthusiasts began seeking out the machines that had defined the power of the 1960s, and the 427 side oiler quickly became a prized gem. Values of original Shelby Cobra, 427s, and Ford GT40s skyrocketed, with many fetching over $1 million at auction. But supply was extremely limited. Only about 300 street-legal side oiler blocks were ever produced, most either destroyed or locked away in museums and private garages. Carroll Shelby saw the opportunity. In the late 1980s, he launched the Continuation Cobra program, building new Cobras with CSX chassis numbers continuing from the original series but using modern manufacturing techniques. The problem? The side oiler was extinct. To preserve authenticity, Shelby American partnered with foundries and engineers to recreate the 427 block from Ford's original 1960s blueprints. The new engines retained the signature side-mounted oil gallery, cross-bolted mains, and high compression ratio, but incorporated improved materials and machining for greater durability and compatibility with modern fuels. As a result, the Continuation Cobras didn't just wear the legend's shape, they carried its true heart, a reborn side oiler. This revival not only satisfied collectors, but cemented the side oiler's status as a timeless icon, bridging the golden era with the modern age. Today, the 427th side oiler is remembered not just as the engine that beat Ferrari at Le Mans 1966, but as a symbol of the perfect balance between power and durability. It represents an era when engineers dared to push limits, willing to invest cost, time, and risk to build a machine with no compromises. From NASCAR, drag racing, and SCCA road courses to the legendary Shelby Cobra and GT40, the side oiler left its mark on every arena, creating a technical legacy that stands the test of time. If you enjoy stories about the great machines that changed racing history, don't forget to subscribe and share this video. Leave a comment. What do you think would have happened if Ford had never built the side oiler? Would Ferrari have kept dominating forever?